These are the formulas which we will be using in your kinematic topic for equation of motions and areas and the gradient. So we will solve one by one questions, and according to these questions, I will let you know which formula will be used and how it is going to be calculated there. Question number 1. The diagram shows the velocity time graph for the motion of a machine's cutting tool. The graphs consist of the 5 straight lines segments. The tool moves forward for 8 seconds while cutting the and then it takes 3 seconds to return to its starting position. Find the acceleration of the tool during the first 2 seconds of motion. Part 2. The distance of the tool moves forward while cutting. Part 3. The greatest speed of the tool cutting during the return to its starting position. So this will be solved like this. This is the graph they are shown, and there are 5 line segments. O to A, then A to B, then B to C, and then C to D, and then D to E. We know that at the point O, the coordinates are 0, 0. For this position A, the coordinates are 2 and 0.18. So we will be using for the first part the acceleration during the first 2 seconds. So acceleration is equal to, we can use this formula number 12 for this acceleration, and that is equal to V2, that is 0.18 minus V1, that is 0, over 2 minus 0, and that is 0.18 over 2, and that is equal to 0.09, and the units for the acceleration is meter per second square. Or you can use the second method, V is equal to U plus AT. V is the final speed. So at the final speed, it is at the position A, which is equal to 0.18. U is 0. It is at O. Acceleration we are going to find out, and the time is there 2 seconds. So acceleration is again equal to 0.18 over 2, and that is equal to 0.09 meter per second square. Then in the second part, they are calculating the total distance traveled while moving forward. We know that from this graph, it is moving up in C position in the forward direction. So area under this is the total distance traveled there. So distance is equal to half into h into sum of parallel sides. This is the area of the trapezium there. So that is equal to half. Height is there 0.18 into sum of parallel sides. This is 4. So that should be equal to 8 plus 4. And that thing is equal to half into 0.18 into 12. And that thing is equal to 1.08 meter is the distance traveled from O to C there in the forward direction there. Then they are asking for the third part, the greatest speed while it is returning back to the position starting there. Since this is the region that is going to move in the backward direction, so this area is same as the area of this OABC is equal to area of this triangle CDE. So we know that distance is equal to velocity into time. And here distance is equal to area under this curve. So that is equal to half into the base is CE and the height is this D F. So that thing is equal to 1.08 because it is the same distance it has traveled. So distance should be equal to 1.08 into half. The CE length is equal to 11 minus 8, that is equal to 3 into df is the height, and let's say that is equal to v. So v is equal to 1.08 over 1.5, and that thing is equal to 0.72, and the units for this one is meters per second there. So this is the complete solution of this problem number 1 for this kinematic, where we are going to calculate the gradient, distance, and the area of that part there. And now we will start question number 2 after this.